S-CP.B.6 worksheet 1, all about conditional probabilities. Now, conditional probability implies something. It implies that something has just taken place before it. So a conditional probability requires to be at least the second or third or fourth event in the chain of events, because it's conditional on what just took place. So the notation that gets used is this. It says, what's the probability of event A happening given that B has taken place? Now, B could be the pulling of a marble. So you pull the marble out, that might be it. And now we're asking the new question, what's the chances of A happening given that something has already taken place? And then this refers to what's the probability of B happening given that A has taken place. Now let me try and give you a visual understanding of what this is ultimately going to calculate. This says given that B has happened, so in the Venn diagram we know that B has already happened. So it basically says, okay, it's none of these things. We're in this boundary now because B has happened. What's the chances of getting an A event? Now, most of A got zapped there, but this area, which is the intersection, A and B, is the only region that still could get you any A values. So your chances of getting A now is the intersection over that whole region. This is how you calculate the probability of A given B. You say, okay, the only way to get A is in the intersection out of the B values. Now I want you to notice that that's no longer out of the universal set because we've determined that we are inside of B now, and so we are not out of the universal set, we're out of just the items in B. The same thing is true here. If we said, what's the chances of getting a B value given that A has happened? Well, what that means is A has already happened. The coin has been flipped, the card has been picked, and the only way to get a B value is in that intersection of A and B over the probability of A, because it's the only thing that remains in here. Now, this gets used in lots of different ways. They might say to you, in the bag, let's say there are 5 white and there are 2 black. And it might say, what's the probability of getting black given that a white was previously selected? So let's think about that. So you've got the original probability of white is 5 out of 7. The original probability of black is 2 out of 7. But the conditionality says in we went and we grabbed a white one and, let's say, kept it. Okay. So out it comes. What's the chances of getting a black? What's the conditional chances of getting a black? Well, there is still 2 blacks in there, but there's 1 less marble. A conditional statement sometimes changes the probability. Here, the original probability was 2 out of 7. The new probability is 2 out of 6. Later, we'll discuss something called independence, and that will be an important part. But if one thing impacts the other like that, then they are not going to be independent. Now, let me just show you a nice little trick. Let's grab that white marble and put it back in. Had we put the marble back in and then said, what's the chances of getting black given that we had a white but put it back? Well, actually, then we would have an independent world because those things are going to stay the same. Let me just see here on my sheet if there's anything else that I want to say about conditional statements. Ultimately, a conditional statement is written in this fashion, and it's calculated based on what has just previously taken place. So for instance, let's use a deck of cards. Where's my cards? Here they are. And if I said, what's the chances of getting a 4 given that a 10 was selected and kept? not replace. So a 10 came out of the deck, whoop, dropped it down. What's your chances of getting a 4? Well, let's see. There are 4 4s in the deck. But I took one of the 10s out and it's out of there, so it's out of 51. This is the conditional environment. Now, conditional environment matters a lot about the words replacement or non-replacement. Replacement means put it back in the deck, and then non-replacement means to keep it out. And you get the idea that non-replacement is an important trigger for change, right? Good luck with these guys. Conditional ones are quite a bit of fun. Actually, maybe just quickly in a chart, I shouldn't have summed up too quickly. In a chart, let's say we have people that like Nike and Reebok, and we have boys and we have girls. Let me just put some numbers in here. 5, 7, 10, 1, let's see here, 12 here, 11, 23, 8, 15. Let's just say we gathered some information about boys and girls, whether they are wearing or like Reebok or Nike shoes, let's say. Now, a conditional statement would be, what's the probability of liking Nike given that you were a boy? Now, what I love about conditional statements in a column, like in a two-way table, is it says given that you're a boy, so you can ignore everything else in the table, right? We are just now worried about being a boy because that's what we've been told. And the chances of liking Nike are 5 out of the 15 because I am only in here. Notice I'm not out of the universal set. I'm out of that probability of that event happening and only that event happening.